So when we look at really America leading the way in technology and AI, when we look at business and government, right? So public sector, private sector, committed to growing U.S. manufacturing, and then the electrical infrastructure and the energy to power it. I'm really optimistic that we will have the right policy framework, investments, and environment to move all of that forward.
Hello, everyone. I'm Barbara Humpton, CEO of Siemens USA, and you're listening to The Optimistic Outlook. Earlier this year, I recorded an episode with Olympia Brickis, our head of AI research at Siemens. That episode spotlighted an area of AI that isn't getting as much attention as consumer applications, and that's industrial AI. You might also hear the term physical AI. That's how Jensen Huang, CEO of our partner NVIDIA, refers to it. And in fact, Jensen also refers to Siemens as the operating system for the work ahead for transforming the physical world. This is a topic I want to continue focusing on in this podcast. With Olympia, we heard from a technologist who has deep expertise in bringing AI to industrial environments. Olympia highlighted the new industrial co-pilots we've developed with Microsoft to make manufacturing technologies easier to use. In this episode, I want to introduce you to policy experts who bring two unique perspectives. First, the potential for industrial AI to help revitalize American manufacturing. And second, the role that government policy can play in supporting America's industrial AI leadership. What I'll bring you in a moment is a panel conversation Siemens convened with our partner, the Information Technology Industry Council. This was part of a lunch and learn session we co-hosted at ITI's annual event, the Intersect, a tech and policy summit held in Washington, D.C. And I want to thank Senator Amy Klobuchar for speaking at the lunch and learn and all the attendees who were with us that day. The panel session you'll hear was moderated by my colleague, Bree Saxe, Senior Vice President and Head of Government Affairs at Siemens. Bree was joined by two members of the House Science, Space, and Technology Committee Research and Technology Subcommittee, Kate Johnson, Staff Director, and Alan McQuinn, Professional Staff Member. You'll also hear from Jerry Petrella, General Manager, U.S. Policy for Microsoft, and Eric Breckenfeld, Director of Technology Policy at NVIDIA. This conversation covers some inspiring examples of industrial AI in action. You'll hear commentary on the importance of workforce development, policy recommendations, and more. We're going to pick it up here with Jerry talking about the industrial co-pilot. Take a listen.
It's an exciting moment because I feel like there are multiple streams crossing at once when it comes to U.S. public policy priorities where the government and industry have to work together on certain challenges. I think there's a bipartisan consensus. We want the U.S. to lead the world in AI innovation and AI development. There's also a bipartisan consensus that we want to bring advanced manufacturing, particularly in critical sectors like semiconductors, back to the United States. And those two things are happening, but they're also converging. You just heard about the industrial co-pilot we launched together, Microsoft and Siemens, and how that's actually bringing AI to the factory floor to create the factory of the future. I was amazed last night. I was trying to get ready for the panel, and I was watching some videos of this in action. And you essentially see factory workers, right? People that are already really smart, engineers and folks that are skilled in trades, essentially talking to an AI agent, interrogating it, asking it questions about where there are flaws in the system or where there can be improvements made in the system. My mind was blown just watching this. So something that probably used to take days, weeks, or months can now be wrapped up in a matter of minutes. You can move on, make your system, make your floor more efficient, more productive.
And Eric, talk a little bit about NVIDIA's view or applications, but can you also maybe just explain the industrial metaverse concept to this group as well?
I think that when we ask ourselves, what are the ways in which intelligence writ large can change the manufacturing sector? You kind of have to break it into a lot of different components because there's the intelligence that I'm utilizing before I ever go into a factory at all. This lives in the simulation space. So this gets to questions of how am I modeling what I intend to do? How am I exploring different configurations of a factory or perhaps asking for recommendations from my simulation system for something that my human intelligence is never considered before as a way to arrange a factory floor or as a way to improve the process. This ties into how humans move about the factory floor. This ties into questions of industrial work and safety. Where are there likely touch points of human workers to equipment, and how might I improve that to reduce odds of worker injuries? But then also the equipment and automation itself. How is it optimized with respect to the rest of the automation equipment? Where are places where I ought to be introducing new pieces of equipment for automation? But I can think of something on the far other end of the complexity spectrum. I can think of semiconductor manufacturing, for example. This is a hundreds or even 1,000-step manufacturing process where each step has extremely complex physics involved. How do I start to go into large quantitative models to look at those, plasma physics informed steps? How do I look at how each of those stacks up, and then how I have better end-to-end yield? This all is in a space that has so much data and complexity that, I'm a material scientist by training. We do our best.
We couldn't tell.
We do our best to improve the efficiency and yield of these, but there are limits to what human intelligence can do with, 1,500-step processes. And so these are areas where intelligence is a great augmenter to what human intelligence can already provide.
I'd love to draw Kate and Alan, you into the conversation as we think about unpacking the tech, and then maybe talking about, bill text and drafting the policy solutions, right? So when we see the potential for AI to really drive U.S. manufacturing, talk kind of about what you're seeing from your vantage point.
One of the challenges that we have in Congress is members think of AI as AI, like broad reaching. And I think one major challenge that we have and you all have is educating members on what industrial AI is and the promise there. I think also there's an opportunity with this administration and Congress right now to look at what red tape is there that's prohibiting the growth and adoption and demonstration of these programs. The Science Committee is a non-regulatory committee. We look at innovation. And so we're looking at it and what is the federal government's role in examining the promise of industrial AI, the scaling of AI, and the partnership with industry. I'll let Alan, let's jump in.
I would have foot stomped everything Kate just said, but maybe I can talk a little bit about barriers and challenges in this space and kind of the questions that we think about on the Science Committee. I think there are three major questions as it comes to industrial AI. The first one being, how do we improve trust in the technology? Our committee took up a number of bills last year on a bipartisan basis to really improve the evaluation of AI in a given context or use case. How can we really understand or compare different models? And I think that's true in the manufacturing sector as well. Like, how can you make sure that this thing is doing what you want it to be doing? We want to advance the science of evaluation. We're focused there. A second major question is on how do you advance the state of the art? As Kate said, we have a number of science agencies who are really aimed at this problem. One of the major programs here is the Manufacturing USA Institutes and Networks. They just announced an AI-focused institute for supply chain resilience. I think we're tracking those programs. We're trying to understand how our members can get involved. And the third one is on adoption. Now, as Kate said, the Science Committee has relatively few policy knobs and whistles that we can pull as it comes to adoption. But one program that is incredible, if you've never heard of it, is the Manufacturing Extension Partnership, which has been around since the 1980s and really helps small and medium-sized companies in every state across the country to adopt AI, to adopt cybersecurity, to improve their practices and update technology. And that's one of the, I think, one of our golden programs that we have in our jurisdiction.
That's a great segue, Alan. I think we've got 90% or a large tranche of manufacturers in the U.S. are small to medium manufacturers. So when you think about going through a journey of how AI can bring manufacturers along, we want to make sure in an industrial environment, right, that it is reliable, secure, trustworthy. Alan and Kate, let's go back to you again on from a policy perspective of how can we collaborate together, right? Whether it's policies, investments, maybe it's more on the manufacturing institutes or the extension partnership, MEP, but really preparing workers for an AI-driven manufacturing world.
When it comes to manufacturing workforce, I think one of the ways that we look at it is this huge chicken or the egg problem, where small and medium-sized manufacturers need to both buy the technology and have a trained workforce to use it. And there's kind of sequencing challenges there. I think really what we're going to need is an approach that attacks it from every angle. So we need to look at the skilled technical workforce. We need to look at incentives to adopt technology. We need to look at every type of regional innovation program that we can muster to really address some of these challenges. And I'll also put it in the context that there's currently an aging population challenge in many small and medium-sized manufacturers at a time that a lot of people don't want to get into this workforce to begin with. So if we don't address the problem with a sense of urgency, we could see a lot of these businesses just end.
And I think to Alan's point, we've been thinking about this for a long time. I think STEM education overall is a challenge that we continue to face. But as we look about it from the Science Committee's perspective, I think we, again, are looking at it from the research angle. What are innovative approaches that can be proven and then scaled? So NSF does the ATE programs, which partner with community colleges to do training programs in critical technology areas, whether that be advanced manufacturing or biotech. There's lots of opportunities there through that program, and it is heavily supported bipartisanly in Congress, but NSF has limited bandwidth, right? They support the program to develop curriculum and it's successful at one place, but then how do we scale that and reproduce it at 25 other community colleges? And that's not really the National Science Foundation's purview and responsibility. So how do we partner with industry potentially to adopt these and find successful programs, or vice versa? What are the red tape and restrictions that are keeping you all from thinking creatively and partnering with local community colleges and the federal government to do some of these programs? Should we be examining what those focus areas are and readjusting them given the new challenges of the world today? I think those are all questions and things that we're open to discussing. Last year, we did a couple of AI education bills through the committee on a bipartisan basis. What are the fundamental skills to be AI literate? What is the baseline that students and reskilling needs to properly interact with AI confidently and comfortably? I think it's something our members and our chairman are very interested in diving into.
Well, and Jerry, let's maybe pivot. Recently, we saw Brad Smith pen his view on workforce and not really doubling down, I think, if I'm saying this right, on kind of software developers, coders, but around electricians.
It was an interesting op-ed because so much of the conversation here in DC when it comes to AI and energy is about how much electricity we're going to need to power AI, to power data centers. There's a little bit less conversation around, or perhaps no conversation around, the skilled workforce we need to build out that AI infrastructure stack. And that was what Brad was touching on. We see a huge need for not just electricians, but other skilled trades that would also be applicable in the manufacturing space, right? And in addressing a potential workforce shortage that we're going to see over the next few years. There's about 800,000 electricians in the country today. We see a retirement rate around 30% over the next few years. If you look at the increased demand that companies like mine and others that are electrifying certain industries, there's potentially a shortfall of hundreds of thousands of electricians, other skilled trades, pipe fitters, folks like that. And so we actually need to have not just an industry approach, because industry can't do it all alone by themselves. We need to partner with policymakers and have a national skilling strategy around these issues. In Brad's op-ed, he mentioned that we got rid of shop class in school. Growing up, it was essentially go to college or else, right? We I think, trained an entire generation to think that there weren't many other options than four-year schools. And that's just not the case anymore. I mean, the final thing I would say is there's a role for public policy, right? I think Congress can push some things across the finish line. There's a couple of proposals out there on short-term Pell. There's proposals on new tax incentives for workforce training. You know, Microsoft and companies like mine are going to do our part. We're working with community colleges to design AI skilling curriculum. We're working with labor unions. We're working with teachers and others to actually give them some of our AI tools, put them in the classroom, put them in the training facility. But we can't do it ourselves, Bree. We're going to need that public-private partnership.
No, I fully appreciate that perspective. So Eric, over to you from a workforce kind of ecosystem and how NVIDIA is looking at transforming the landscape.
Yeah, before joining NVIDIA, I was at the Semiconductor Industry Association at the height of the passage of the CHIPS Act. We did a workforce study and found that between 2023 and 2030, we expected about 100,000 new jobs to emerge in the semiconductor space in the United States. This was across manufacturing, design, other. And if we looked at current pipelines for all of those roles, we found that about 60,000 of those were missing. And when we looked at the character of who was missing, about a third were in this, what I would call the skilled trades. And the challenge with a lot of those is how regionally focused they needed to be, where, really the folks who got training in those tasks probably were going to be seeking a job in a zip code in or adjacent to where they got that training. And so when we look at where the pipelines for those workers, it needed to fall into these partnerships with technical colleges, community colleges, with state and local governments. And, I think that was tilted very specifically towards the semiconductor industry, but I think you can kind of drag that across to other manufacturing sectors. And especially, I would say, on the topic of AI training for these workers, the concrete isn't dry on what skills are needed. That is being discovered. And that's why the partnership side is so important. What we don't have is fixed curricula that's 20 years proven and you all just need to adopt it and get in line. That is not how this is operating right now. We need input from anticipated users. We need input from students, from educational institutions. So I think there's an opportunity for, what I might call like a community and technical college renaissance to explore what curricula is valuable. And there's a great opportunity there. We're very excited. We have a platform called the Deep Learning Institute that we share that's always in development that we share with local institutions. So I think it's a great time for that, and I think partnership is exactly what's needed.
We're going to move to the lightning round portion of this lunch. We can start, Kate, with you on the policy debate. We see a lot on the consumer-facing side, but from the industrial landscape, kind of call to action or just really a kind of a crisp view that you'd say on the policy front. So we'll go through each one of you to share a perspective on that.
We need to examine what role NIST, the Manufacturing USA, the MEP programs can play in helping adoption, standardization, best practices and frameworks that can help industry create standardization for this adoption.
We want to hear from you all about what you think should be happening in manufacturing. We want to hear about the importance of the programs that we've already established, whether it's the Manufacturing USA Institutes or the MEP program. So if you benefit from that, if the small and medium-sized manufacturers in your areas buy your products because they've been taught to digitize by these centers, we want to hear from you. Policymakers want to hear from you. This is the time to get engaged.
I'll say let's target policy and federal resources to those sectors of the economy that are where we're having the AI build out, where we're having the semiconductor manufacturing fab build out. If we see workforce shortages around the corner, let's target DOL grants, DOE grants to those community colleges and those partnerships where we're actually seeing huge investments of capital from companies like mine and so many others in ITI and around the room. I think there's a need for being really, really targeted and not just spreading very finite federal resources around. We've got to be really sophisticated about it.
Yeah, I'll echo having a targeted role of government and kind of bookend back to the original comments. I think that it's a very fruitful area for government working with industry to help set best practices. But if we look at the industrial AI space, AI providers and customers want to proceed in a way that is safe in application, safe around data. These are all very valuable areas for both the providers and the customers. And so I think in a situation like that, the best role of government is to work with the providers and the customers and help adopt best practices, because everybody wants to be on the same page about safety in this. So this doesn't need to be something where it's viewed as the government, telling companies to do something they don't want to do. Safety is desired in this space, and it's about sharing and identifying best practices.
Great. Second part of our lightning round as we wrap up. So I'm going to take the optimistic outlook view of our CEO. So I'd love to hear from each of you what you're optimistic for in this year in terms of the policy landscape. And I will go first. I am enthusiastic about this administration and this Congress really in the opportunity to set the tone in a tech-driven growth and innovation agenda for the U.S. So when we look at really America leading the way in technology and AI, when we look at business and government, right? So public sector, private sector, committed to growing U.S. manufacturing, and then the electrical infrastructure and the energy to power it. I'm really optimistic that we will have the right policy framework, investments, and environment to move all of that forward.
I would say I'm optimistic about innovation forward. I think that this administration and Congress are looking for ways to think creatively to these approaches. So some of it may look like breaking things in order to see what comes out of it, but I think on the optimistic side, that's a way to re-examine and look at new approaches that aren't buried in 20 years of bureaucratic process or anything like that. So I think there's opportunities there. We just have to find them and present them to the right folks. So working all together to do that is a huge opportunity.
I'll say that 5 years ago, we did really big things with the previous Trump administration. We did a National AI Initiative Act. The year before that, we did the National Quantum Initiative Act. We did a reauthorization of RAMI, which is the Manufacturing USA Institutes. We did the Chips for America Act. Hopefully, we can pick up some of those efforts.
I'll build on that and say I'm optimistic, even though it seems rather partisan and difficult right now in Washington. I'm optimistic that there's bipartisan consensus on AI and manufacturing, energy, and workforce. And across those three issues that actually need one cohesive policy for us to win this AI race and this manufacturing race, I'm actually pretty hopeful we're going to see both executive action and something in Congress move that complements all three of those issues. So that's what I'm optimistic about.
I truly believe that we have an opportunity to enter a new golden age for U.S. manufacturing and innovation. And I think that it's going to require the flexing of some muscles that maybe we've let atrophy a little bit. But I think that it's bipartisan to learn how to do those things again. I think that standing up a new wave of energy infrastructure, I think that that's bipartisan. So I think that as long as we, in a sense, get out of our own way and make sure that we're bringing all the stakeholders that we need to solve these problems, it's there. And this is an area, especially integration of AI into manufacturing. I think it's an area that the U.S. is poised to lead in as long as we make the correct set of decisions in the near future that again, I think are relatively bipartisan.
I hope you enjoyed this conversation. Thank you again to ITI and our partners who joined Brief for the conversation. I had a chance to testify on this topic before Congress with ITI President and CEO Jason Oxman earlier this year. I'll add my comments to the show notes. And let me quickly share one point I made. Conversations are continuing about how to best guide AI development in America. And it can be tempting to apply one big paintbrush to AI, to sweep what we're working on in industry into the broader AI category. But industrial AI is very different from consumer applications, which, yes, do present risks across society. Consumer AI pulls large swaths of data from many open sources. Industrial AI, on the other hand, uses secure data sets coming from sensors in a controlled environment. Siemens is then taking advantage of decades' worth of experience developing machine learning. This enables us to put this data to use to create business value for customers. Did you know that in manufacturing, 80% of that data that gets generated is wasted? Well, we're now able to capture this data and draw conclusions that would literally be impossible for any one of us to do if we were standing on that factory floor. We've been encouraged to hear government leaders supporting an approach that does not apply that broad brush, that helps to guide AI development in a way that balances innovation and safety. We see industrial AI as a tremendous example of how this world-changing technology can positively impact the U.S. economy, our workers, and society writ large. Keep listening to this podcast to learn more about this topic, and I hope you'll go now to our show notes for more resources. See you next time. please follow us on social media and on your favorite podcasting platform. Thank you for tuning in.